For this lesson, we're going to be looking at the applications of sine law and cosine law. So a few important things to note before we get started. Firstly, if there is not a diagram included, make sure you sketch a diagram. These questions are almost impossible to solve without a diagram. Next, make sure you've labeled all of your triangle, and then we'll decide which law we will use. So all of these questions have a mix of sine law, cosine law, and there are a few SOHCAHTOA problems thrown in there with some right angle triangles. Finally, make sure you round all of your angles to the nearest degree and round your lengths to 1 decimal place and include units. So let's get into our first example. So a smokestack AB is 205 meters high. From 2 points, C and D, on the same side of the smokestack's base, the angles of elevation to the top of the smokestack are 40 degrees and 36 degrees respectively. We want to find the distance between C and D. So I'm going to start by labeling what we're looking for. So we're looking for this distance right here. Now there's a few strategies to approach this, and I'm going to go through how I like to approach it. If you're approaching it slightly differently, that's okay because there's loads of ways to start finding values on these triangles. So the first thing I like to do is to find any missing angles that I can find at this point. So the first one I can find here is this angle C here. And this whole angle here, from here all the way over here, is a supplementary angle. That whole orange semicircle is 180 degrees. So this dotted part uses up 40 degrees of the semicircle. So to find the solid part, we need to find what's left of that 180 degrees. So I'm going to do 180 minus 40 degrees will give me 140 degrees. So this angle here is 140 degrees. Now that we found that angle, we can also find this little teeny angle up here. So all of our angles in a triangle add up to 180 degrees. So this angle over here is going to be 180 minus that 140 from angle C minus 36. So there we're left with 4 degrees. And finally, just to be safe, let's also find this one here in this triangle. So over in this triangle, we have 180, we have that 90 and 40, and that leaves us with 50 degrees. Now, when we go through this, you'll notice you didn't need to find all of these angles, but it is a good place to start because it can help you figure out which laws to use later on. So now that we've done that, the next thing I'm going to do is I'm going to start trying to figure out which pieces of information I need. So we have two triangles here, and I'm going to start by separating my triangles. It makes things a lot easier when you separate your triangles. So in order to do that in a video without actually being able to show you what I'm doing, I'm going to color the triangles differently. So this right angle triangle here, ABC, I'm going to make our green triangle, and I'm going to make us a pink triangle that's ACD. Now I'm going to write out these triangles separately so that we can get a better look at what pieces of information we need. So here's our green triangle. And again, anytime you're drawing your own diagram, be mindful that it will not be to scale. So just do the absolute best you can. But if it's not to scale, it's probably because your drawing is a little off. So don't stress about that. So that's our first triangle, and then our pink triangle looks something like this. Again, they're not the most accurate, but I'm trying my best. And now let's put in our values. So that's x. This is 140 degrees. This is 36 degrees. This is 4 degrees. We have 50 and 40. Okay, so if I'm looking at my pink triangle, I want to start thinking about which information I have. So I'm trying to figure out x, which is the distance between C and D. Now, it's not a right angle triangle, so I'm thinking about sine law and cosine law. Well, I don't have any full pairs here, and I don't have enough information for cosine law either. But there is a way that I can get enough information. If I look at my original diagram, both triangles share this side here. So if I can manage to find that side length on the green triangle, I can use it for the pink triangle. So let's go over to our green triangle and look here. It's a right angle triangle, and I'm looking for this side here, which I'm going to call y. Now, because we have both angles, we can circle whichever one. I'm going to circle the 40, but it doesn't matter. And now I'm going to label it like a right angle triangle. So the side across from my right angle is my hypotenuse, and the side across from the angle I circled is my opposite. So I have O and H, which means I'm going to use sine x equals opposite over hypotenuse. So for this, we're using SOHCAHTOA from last unit because it's a right angle triangle. You can actually use sine law and cosine law on right angle triangles. It works perfectly fine, but SOHCAHTOA is more efficient, so usually we go that route. So sine of the angle we circled, opposite is 205 over y. Now having that y on the bottom is causing trouble, so let's multiply both sides by y to get it out of the denominator. Y sine 40 is 205. Now we need to just have y all by itself. So I'm just going to divide both sides by sine 40. Divide by sine 40. So y is equal to 205 divided by sine 40. So that gives me that y is equal to 205 divided by sine 40, which is 318.9. So if I go to my original diagram, this y here is 318.9 meters. And I can also put that on this triangle here. Now I look at my triangle and I'm going to see if I have enough information for sine law or cosine law. So when I'm trying to determine if I have enough information for sine law or cosine law, I want to start looking for full pairs and half pairs. So I'm going to first label my triangle. So little a is across from big A, little d is across from big D, and little c is across from capital C. Now I'm going to look for a full pair, and I have a full pair with D and D, and I have a half pair with my A's here, right? I have the 4 as well as the X that I'm looking for there. So because I have a full pair in D and a half pair in A, I can write out my sine law. So I'm looking for a side length, so my lowercase letters go in the numerator. And because I've already labeled my triangle, filling in my equation is pretty straightforward. So little a is x, sine 4 equals 318.9 all over sine 36. Now, because I have a fraction equaling a fraction, I can cross multiply. So we have x sine 36 equals 318.9 sine 4. Now to get x all by itself, I need to divide by sine 36 here and divide by sine 36 over here. So x is equal to 318.9 times sine 4, all divided by sine 36. And that will give us 37.8 meters. And that is our final answer. Now, the last thing is, because I had words in my question, I need to have a therefore statement. So I'm going to say, therefore, the distance between C and D is 37.8 meters. Now that question is very challenging, but the more you do them, the better you'll get at recognizing what information you need and what information you're able to get. But usually there's one side missing, and you can use SOHCAHTOA or Sine law or something to find it, and then you can find the other side. Okay, let's do another one. So for number 2, two roads separate from a village at an angle of 37 degrees. Two cyclists leave the village at the same time. One travels 7.5 kilometers an hour, and one travels 10 kilometers per hour on the other road. How far apart are they after 2 hours? So no diagram is given, so we need to draw one. So let's start at our village right here. And we have our two cyclists. Cyclist number 1, or cyclist A, we'll call them, goes this way. And cyclist B is going to go this way. And what we want to figure out is how far apart cyclist A and B are at the end of 2 hours. The next piece of information we're given is that they go at an angle of 37 degrees, so we can put that in. Next, we're given their speeds. So, cyclist A is going 7.5 kilometers an hour for 2 hours. So, they go 7.5 in the first hour and 7.5 kilometers in the second hour. So, to figure out how far they go is 7.5 multiplied by 2. So this side is 15 kilometers. So that's what goes here. And cyclist B is traveling at 10 kilometers per hour. So they go 10 kilometers in the first hour and 10 kilometers in the second hour. So to find out how far they go, we do 10 multiplied by 2. So they travel 20 kilometers. So that's what goes here. Just going to erase those because we don't need them. All right, so what we're trying to find is this length here, which I'm just going to call x. So now we start by labeling our triangle. So we have our capital letters on the angles, and now across from each angle, we need to put the matching lowercase letter. So across from capital V is lowercase v, across from capital A is lowercase a, and across from capital B is lowercase b. Next, I start looking to see if I have a full pair and a half pair. If I look here, I do not have a full pair, so this is a cosine law question. You may also recognize that this has our two side lengths with the value of the interior angle given. That is a classic cosine law question. So if you've done a lot of cosine practice, you'll start recognizing this situation right away. Okay, so we're looking for side little v. So we'll put little v there. Then we have our other two sides squared minus 2ab cosine of v. And now that I've labeled my triangle, it's very straightforward to plug all my values in. So v squared is 20 squared plus 15 squared minus 2 times 20 times 15 cosine of 37. So if you have a double-lined calculator, I would highly recommend putting all this in at one time. I just want to make sure I go through all of the steps so that you can see everything, especially if you don't have a double-line calculator. But if you do, I would highly recommend you just plug in this whole thing to avoid any errors. And we have v squared is 400 plus 225 minus 479.18 which is 145.82. Now that is v squared, but we just want plain old v, so we're going to square root both sides. And that gives us that v is 12.1 kilometers. And you always want to look at your answer and think, does this make logical sense with the question? Don't get too caught up in your diagram because if you drew it yourself, it's likely not perfectly to scale. But we have 20 and 15 as the other side lengths, so 12 makes sense. So our final step is to write our let statement. So we'll say, therefore, the cyclists are 12.1 kilometers apart. And that's our final answer. So in comparison to the first question, this one is a lot more straightforward. The first question is basically as hard as these things get, but this question is a perfect example of a pretty standard sine law or cosine law question. All right, let's do one more example. So a radar tracking station locates an oil tanker at a distance 7.8 kilometers and a sailboat at a distance of 5.6 kilometers. At the station, the angle between the two ships is 95 degrees. How far apart are the ships? So we have our radar tracking station here. And if you've drawn your diagram a little bit different from mine, that's totally okay. There's definitely room for interpretation here. So just be mindful of that when you look at your diagram and if maybe it was rotated from mine. So from our radar station, we have an oil tanker that is 7.8 kilometers away. And then we have a sailboat, which is 5.6 kilometers away. Sorry, that line was not even close to straight. That's not much better, but what can you do? And we're looking for the distance in between the two ships. So we're looking for this distance here, and I'm just going to call that x. And the other piece of information is that these are 95 degrees apart. So in order to figure out if this is a sine law or a cosine law question, I always start by labeling my triangle. So across from capital R is lowercase r, across from capital S is lowercase s, and across from capital O is lowercase o. I'm trying to make them look different, but they kind of still look the same. Now I look for a full pair and a half pair, which I do not have. But again, we have this two sides and their interior angle situation, which is our classic cosine law situation. So if you're struggling with the pair business and you see that situation, it's definitely a cosine law. So now that we've labeled our triangle, let's figure out our cosine law equation. So we're looking for a side length. So we have r squared. And now we fill in the rest with the appropriate letters. So we have our other two sides squared minus 2 times our other two sides, cosine of r, the matching one to the side we're finding. Little r squared is equal to, now I'm just filling in all my values because I've labeled my triangle so nicely. There we go. And then you can just plug this whole thing into your calculator if you have a double line calculator. So for this time around, I am going to do that. Even if you don't do that, you should get the exact same answer if you do it in multiple steps. So I got that r squared is 99.81, and that is r squared, but we just want r. So in order to get rid of that squared, we're going to square root both sides. So r is equal to the square root of 99.81, which gives us 10.0 kilometers. Oops, there we go. And because this is a word problem, we always need a therefore statement. So we can say, therefore, the ships are 10.0 kilometers apart. And that is our final answer. So again, this one was much more straightforward than question 1, but it's a good thing to do all types of questions. So there are a few practice ones for you below here, and I've done all of the solutions to them and tried to break it up as much as possible. And if that is not enough and you feel like you need more practice, I've added a bunch of extra homework questions for you to do, but they are optional. If you feel like you get it and you're good to go, you can just do these ones.